Hello, everyone. Thanks for joining in. Welcome to this session on functional fix, in which Hari will be talking us about the Kotlin error handling. So thank you, Hari, for joining us today. So without further delay, I would hand it over to Hari.
Thanks, Anupa. Thanks a lot for the introduction. Hello, everyone. My name is Hari Krishnan, and I will be talking about the functional fix today. So I'm going to be talking about Kotlin error handling made elegant, and this is quite a topic that's close to my heart because I've written this code and have been living with it for the past 5 years. So I guess kind of sharing my experience in terms of how the functional fix helped me in terms of handling the errors in my code. So quickly about myself, am co-founder and CTO at Specmatic, and I also run Polarizer Technologies, and I'm a transformation advisor, a coach and a trainer, and I'm quite keen on APIs and generally helping organizations with API governance strategy. That apart, I love communities and conferences. I like participating in them, speaking and volunteering for them. So these are some of the conferences have had the privilege to be a part of, and again, extremely happy and honored to be a part of functional conference. So with that, let's quickly jump into the topic for today. So again, this is an experience report, like what I was saying, right? And the product, or rather the open source code that we were writing for Specmatic some 5 years ago, at that point, we had to work on creating a HTTP stub server, which is based off of a Open API specification. So what we would do is using the Open API specification, we model an HTTP request in memory, right? And it would have like certain qualifying criteria about what a request is made up of, right? Which would be the URL, method, and body. Again, I'm keeping it simple for the sake of, uh, you know, explaining the topic here. I'm sure there'll be more like the content type and whatnot, so I will not get into it. And then once you have extracted this detail out from the OpenAPI specification and I've started a step server, let's say I get an incoming request. I need to figure out if I already have this kind of a request inside of my stub server, and thereby does it match? And then I can take a call on what I should do next. So that would be the matching criteria. Now, stubbing is one use case I'm talking to you about, but there are many such cases, where you have to deal with extracting something from the API specification and matching various criteria for them and figuring out what you need to do basis that. So this is the ask. And typically what we have to do is go about matching request one with request two in a certain order, right? And in a certain precedence. So the URL takes the most precedence. If that is equal, then I'll go to the next one, which is the method. And if that is equal, then I'll verify the body. And in this case, the body, the schema is fine, but of course, the values are different. So thereby it is not matching, right? So that is like one of the examples. And in this case, the expected output should be a failure, and it's got to say the message is body did not match. This is the ask. Now, very straightforward. I think should not take more than 5 minutes to write both the test and the code and test drive it and knock it out, right? And that's exactly what I thought it would look like. And I did write this kind of a mental model in my head, right? Which is I want to start with match URL, then I want to match the method, and then match the body. And that's exactly what has been asked of me. So, and I have done that. This is the mental model. And then I start writing the code. And the code looks something like this. Now, again, like all programmers who are meditating on functional programming, it's important to stare at your code. And I'll let you all stare at this code and just try to see what you can make of it, right? And for me, the first 5 minutes itself, I was just wondering, my mental model was match the URL, match the method, match the body, and then you're done, right? But when I look at this code, it's all about the failure and less about the success. Now, what do I mean by that? Let me clarify. This is the mental model I wanted, but then the actual implementation, the way I'm writing code, is if the URL does not match, it's a failure. If the method does not match, it's a failure. If the body does not match, it's a failure. What is success? The lack of failure is success. Sure, this is still not bad code. It's readable and all that, and we're familiar. but there is some sort of a dissonance between what I'm modeling as the happy path journey, and that happy path journey itself is not being highlighted anywhere here. It's more like the lack of failure is the ultimate journey itself, right? So the happy path is encoded rather, it's not direct. So I was not particularly happy with the code I had written, and this was bothering me for some time, right? So that's when I almost accidentally hit upon this concept called railway oriented programming, a dual track approach to focusing on the happy path. I mean, this completely intrigued me because I I had thought of this situation, and wasn't even able to formulate in my head very well as to what is the problem. It just felt like a dissonance. But then this gentleman came to the rescue, which is his name is Kotlin, and he's very popular for this analogy called railway-oriented programming, or rather, introducing the railway analogy in this area. And this is the blurb from his particular talk, which he delivered at NDC Oslo. Extremely enlightening talk. I would highly recommend all of you watch it. And this is the blog post, which is a follow-up to that video, which is for F Sharp for Fun and Profit. Again, highly recommended reading, irrespective of what I can tell you about my experience. I think all of us have so much to gain from this gem of a piece that has been written and put out, right? So his primary, pet peeve or whatever it is you can see here is also that even functional programming, as we all see, is usually like beautiful composed functions, and they all look very easy to read, and your mathematics are represented superbly well. But in real world, we all have to deal with validation, logging, networking, service errors, like what I was dealing with, right? I was trying to match two HTTP methods and seeing if the match is a valid case. And here, Scott is trying to figure out how we can still maintain that, the beauty of the functional programming about composing functions while still having to deal with the real world pieces, right? So without going further into the theory of it, let me jump straight into what this means. The railway-oriented programming analogy is basically, imagine that you have two tracks. One track is for the happy path and one track is for the errors. Now, earlier when I showed you the code that I had written, the problem I had with that code was that it was heavily focused on the error and practically nothing for the happy path. So now what I want to do is map my mental model. If you see the first line here, it's still the same thing, right? Match the URL, match the method, match the body, and if everything is matching, it's a success. And that's the composition I want to achieve, right? Sure, there can be errors at any point in this journey. And whenever that error happens, I want to shunt or short circuit and then go to failure. Now, this looks like some sort of a two tracks, right? You have one railway track at the top and another railway track at the bottom. The top track is your happy path journey. You're going through all your checks and everything is pretty much right on, and you reach your destination, which is success. But at any juncture, you realize something is not matching. You take a siding, you take to the other track, the error track, and you move on from there. So from the point of view of someone reading the code, they are so much more focused on the success part. The journey is very evident. What is the success? And the error is also evident, and it clearly says where the branching is, right? Or rather, where the error or how is it handled. So that's the beauty of the railway-oriented programming. So the success track is very evident. The failure track is a separate track. And whenever there is a departure from success, you just shunt or short circuit to the failure track. So that way, when someone is looking at the code, it really makes it a lot easier to consume. And even for us to write at the time of authoring itself is very easy. Now, of course, in the context of the small example here, it might seem like a lot of trouble for something less. But if you have to write a lot of such matching code, which we have, and that's the experience report I'm sharing in Specmatic, we have a lot of such matching code. And it is important for us to factor out such machinery of error handling from the primary logic so that the primary logic is still readable, right? So that's where we found it extremely helpful. So let's get into the details of it now. now that I have quickly introduced what the two-track approach here is, right? A code walkthrough in terms of the transformation. Now, I showed you the initial code for how good or bad it is, like in terms of the if conditions and what I initially highlighted. But that said, it would be a disservice for me to directly say, hey, that's bad code. And then I can just directly show you the final code and then say, hey, this is much more better, this is nicer. But you wouldn't then probably this wouldn't do justice to the experience report the stock is supposed to be, right? I have to walk you through the journey of how I refactored it. So I'm going to quickly show you some of the intermediate steps that I had to do also. Okay. So with that, let me jump right into the code. Again, how did I start with this? Obviously, I have my test cases, and my test cases are very, very simple right now. The first one is a happy part test, which is if URL, method, and body are the same, then it should match and it should be a success. So I have two HTTP requests here. One says slash resources get and body, and likewise the other one. And I'm just saying, does it match? And I assert that it's true. So this is a very straightforward one. And when there are mismatches, like if URL is a mismatch here, like resource and another resource, you will get an appropriate failure here, right? And when there is, like there is a difference in the method, that would be a error. And likewise, if there's a difference in the body here, as you can see, it's body A and body B, it would be a difference. So these are the test cases. So let me quickly run this and make sure that it's all running. So I'm just trying to be a good student and trying to make sure I have my tests in place. Now the procedural code, which I already showed you on the slide deck, it's right here. Again, nothing fancy. It's just a bunch of guard clauses so that you can quickly return if there is an mismatch. And if there's a success, you return. And the success and failure themselves are based off of a CL class called result. I have a result type defined because that felt a little bit more nicer to me because I had to wrap the error message or the success into it. So that's why I have a result class. And this also helps us in future, but I will get to it. So this is kind of the procedural code, right? Now, how do I get from here to the railway-oriented programming sort of approach, right? Which is composing functions. So in order to compose functions, first I need to have functions to compose, correct? So what I then did, the first step, instead of boring you with manually extracting it right now, I have a little bit of prep which I've done. And this is the method extraction, which is right here. So the method extraction here is no practical behavioral changes. It's just a refactoring to say, I have in fact increased the number of lines of code in order to decrease. It's almost like I have to expand before I can contract. So I have created these methods, match URL, match method, match body, and each of this now returns a result type. And if there is an error, it will return a failure with the appropriate error message. If there is a success, I'll return the success. Now, nothing changes here. You still have the guard clauses. Only that if it is a failure, I'll return whatever is uh, you know, the result. Again, it's all duplication you can see here, which is probably fine because this is an intermediate step. I do not want to overcorrect right here. So, but this is just an intermediate step. Okay. So that's step number one. Step number one is method extraction so that I can then compose the methods. What is step number two? I have to line up these methods, right? And here's where I'm lining it up. So what I'm doing is instead of the if condition, which I had earlier, I now have to make it a little worse. The guard clauses were actually okay, right? But now I have to do a nesting. The reason I have to do nested if conditions, I will get into it in a little bit. But what I have done here is practically just more got it into a when. And then when there is a failure, I will return. If there is a success, I will further check if it is the next step is fine. So I start with match URL. If it's a failure, I return. If it's a success, I will go into matching the method. If it's a failure, I'll return. Otherwise, I'll match the body and move forward. Again, this is less readable than what it used to be, but things have to get worse before they can get better, I guess, in terms of refactoring. So this was again a baby step I had to do. just so I could get my head clear about it. And once I have this, now comes the most important bit, which is introducing the railway-oriented programming itself. Now, in order for me to compose these methods, right, let's look at the methods themselves. The match URL has to be to say like, I know I have to match URL, then I have to match the method, then I have to match the body. Now there is a then aspect to it, right? If I have to do that, I need to be able to wrap and send to the next setup, right? So that's why when you see the success in the initial stage, the success was a fairly like, the procedural code did not have much. It just took a success and it returned a success message, or a failure also returned a string itself. But when I moved to railway, when I moved to the lining up function setup, I did a little bit of a change. Now instead of uh, you know passing in like just the strings all the time, I have something called a T, which is basically I'm trying to take the generic type. And what is happening here? Let me just rename this for clarity. Let me say this is the value, and this is the error. Now, what does this mean? So when there is a success, I'm returning the value, which the next HTTP request will have to move to the next method, right? So what I mean by that is if I comment out my code here and say match URL, and then I pass it, I have one HTTP request dot match URL, and then I say another HTTP request, right? And then I have to say match method. Now, for me to say match method, I should be able to pass, like I need to have some sort of a then operator here, roughly speaking. And then I have to say match method. And that match method also needs the other, what do you call? The other HTTP request. And then I can go to the match body. Now, for this to happen, whenever there's a success, you return the value so that you can move forward. And whenever there's a failure, obviously you're shunting out, right? You're going to the error track in the railway track analogy. So thereby you return a failure and move forward. So when you get a success, you pass this next object, wrap it and send it to the next station. So the next station can then take it and do something about it. Now hold that thought in your head. The wrapping of the value when you have a success is important, because when we get into the monadic stages of things, this will actually play out as a role. So now I have already done this much. I've wrapped it and pushed it in. Now nothing changes here. This is still the ugly little nested conditions which are working. But the only difference now though is you're working off of whatever is the request which is coming from the previous stage, that station, and then I'm passing it forward. Okay. Now let's move to the ultimate solution here, which is the railway-oriented programming itself. You remember the then operator or some sort of a in between that I wanted. So that's what I have coded here. Instead of me having to manually, in fact, let me do this. I will try to put this on the right, split right, and then I'll keep the lining up functions on the left-hand side so that you know what is happening here. So let me close this. Okay. So earlier you had this monstrosity, right, which I had written, which is I have nesting, which is I first match URL, and if match URL is a failure, then I have to return, and if success, I have to go in and do something else. So this whole if-else condition, right? If it's a success, move to the next stage. If it's a failure, shunt out, right? Short circuit out. This is the duplication that's happening. Again, in the spirit of any refactoring, right? You identify the problem that is the piece that you want to isolate. And where in this case, it's a duplication. Whenever it's a duplication, you want to extract the duplication so that you don't end up making a mistake. Maybe I could, for example, innocently change this from success to failure, right? And that could be a problem, but in this case, it will not be. But I'm just saying, like, why would you want to repeat this? And it just again affects the readability of the code itself. So what I have done now is, instead of trying to rely on repeating the if-else condition for the logic, what I have here is, one moment. What I have here is a then operator, or rather a then function which I've defined, which takes one function as something that operates on the value of whatever has been wrapped and passed in, and then it returns a result, right? So what I've done is, if it's a success, I'll call that next function. So for example, if match URL, and say I'd say then and say match method is being passed to the then as the argument, right? So what happens here now is, when I call match URL and it becomes success, on success, match method will be called. This f will be substituted with match method, and the value which match URL returned, another HTTP request, that will be passed on to this, right? If there is a failure, I simply return right there. I don't call any function. I just say this is the error, and then I shunt out of it. So at least now it's very clear, right? I can pass one method to the other method, and in between there is a then, which is the composition piece. That's how, using the then, I'm composing it. But for this composition chaining to happen, I need to start the chaining, right? So that's where I have this piece called pipe 2. Pipe 2 is basically, I need to say the starting point, there is nobody else passing it on to me. So I'm starting with a success. So I'm piping what? I'm piping another HTTP request to this as a success. There is no failure here. It's the starting point. It's the unit operator. So at that point, I just have to pass the value HTTP request and push it in to this chaining. And now the chain starts composing itself. Okay. Now I told you about chain, how to start the chain, but how do you end the chain? Somewhere this analogy has to end, right? If you remember the dual track analogy, this, if I have come to this track, I need to get out of this track also, and that's the failure, correct? Now for that failure to happen, I need to get out of it, and I need to get out of the wrapping. So now this end state, which is to say handle error, this part is nothing but only failure. It is not, it already knows if there is any failure, I'll handle it. If there's no failure, I'll just get out of it. And that's the beauty of it. So all you have is a pipe to, a then, and an error. And the error function is basically, if this is a failure, else just return it and move out. I'll just let you stare at the code for a moment. And I want you to have a look at, this is important, so I'll keep it in view. But the beauty of this versus this, what I have on the left hand side, or maybe even when I started off, it was all an if condition, right? Just nothing beyond that. Now here you have this composition, and again, a little bit of infix magic here. Kotlin has the infix function, so I'm using the infix notation here so that I don't have to keep calling method notation. I could have done that, but like double colon infix, and now I can directly call the then and the error. Isn't this now looking more like my mental model? I want to take one HTTP request and use the other HTTP request and match URL, match method, match body. If there are any errors, that is, handle it in the end. So someone coming to this code as the first place, they know that the primary algorithm or the primary behavior of this code is to match it in this sequence. And I'm not really looking into the error details. And the beauty of functional programming also is that you get into a, sort of this mechanism where you start composing things. If you have to compose it, you have to have bite-sized pieces. And that's where I have like individual match URL, match method, match body, which are now beautifully unit testable. They don't need to know anything else. They just need to adhere to this particular standard, which is I accept a request, and then when I return it, I'll always return it in a result type. It could be either a success or a failure, right? So far, so good, I hope. But if there are questions, please do put it in the chat, and then I'll be more than happy to answer them towards the end. But this is where I got to, and I was actually pretty happy with it for a day. But that's when it hit me. Sure. I have done all of this, and then I reread the blog, and I think I've read Scott's blog like multiple times now. And I think every time I read it, I get another insight, or maybe the links he's provided to other articles are also extremely helpful. And one suggestion he had given is if you need to understand the concept very well, you need to teach it to someone else, or you need to write a blog, or you need to give a talk about it. And that's good advice in general anyway. So I tried to do that. I tried to write a blog about this, and then I realized something is missing. I may not be like completely done with this, right? And that's when I realized, how about monads? Am I missing something? Because the whole article and the talk that Scott had done, there were references to monad, and so far I had not even written the monad. I probably like just skirting around it, right? But then when it comes to monads, it's always like a little bit of an issue for me, which is I personally have seen the monadic curse with me as well as people around me, which is you ask a question like, what's a monad? Most people might give you this answer. A monad is just a monoid in the category of endofunctors. And then if you ask some more intelligible people, they'll give you some more endofunctor related theory. And then you get into category theory. And yeah, and at that point, I think someone has to go home with a big headache, right? But then I also realized there is this beautiful kind of nicely put together statement. I don't know how true it is, but at least I felt most of it happened to me personally and also to people around me, because I've tried to ask more knowledgeable people in functional programming area to explain to me like what is the problem, but then they have trouble explaining, and that's happened to me as well, trying to explain this to someone else. So the curse is that you learn monads, and then the moment you learn what a monad is, you lose the ability to explain it to others, right? But I want to break that sort of setup and hopefully break the fallacy of monad tutorials here. But that's on a lighter note. Let's look at how we can, this is by no means a monad talk or a monad tutorial, right? I'm trying to use uh, the problem statement that I have in order to learn, and also probably to see how we can apply railway-oriented programming in Kotlin for this HTTP request matching situation, and whether it works in that area or not. So let's try to give it one more shot. So I already have the then operator, I already have the pipe 2, I have the error. I all hand coded that. But what if we could use Arrow KT, a beautiful library which brings a lot more functional programming capability into the Kotlin universe. So Arrow KT has a bunch of operators, the flat map, of course, and then the either monad, which I wanted to use and learn for myself. And that's was the inclination to even start off. So here I find this particular definition a little bit more palatable in the context of this HTTP request matching, right? What is a monad? It's a wrapper around raw values that allows a bind transformation. Okay. This, I think we can at least break it down into two parts. There is a wrapper around raw values. What is the raw value? If you recollect, I was passing the HTTP request from one function to the other as I was composing them, right? So the raw value here are a couple of them, which is on the right and the left. I'll tell you why I'm talking about right and left, but at least you have the error, the value and the error, right? The value is the HTTP request, which is being passed on. And then the error is, of course, the error message itself as to what did not match at a particular station in this particular journey, right? So there are two raw values, okay? And there's a bind transformation which we need. The bind transformation is a flat map, right? Again, I'll get into the detail of the flat map. But basically what we're trying to say is I need a wrapper around the raw values because there are two raw values and it's an either or condition. Let's pick the either monad here. Either monad is a sum type. Again, if you go into ADT, we could do a longer session there. But within the sum type, you have two values like right and left, and the right is the success and the left is the error. So the right, I'm giving it HTTP request, and the left, I will say error message. And then I have flat map. This is my basis on which I started my journey to see if I can learn and implement it. Now let's see how the bind transformation itself works. What is a flat map? It takes a function that accepts the unwrapped value of the either monad. The responsibility, apply the function which it got, right, to the value of the either, right? In this case, whatever is the raw value. And the output, it has to return another monad. So quite similar to the functions that I had actually created, right? The match URL and all. In that case, I was returning a result, which was the wrapped value. But in this case, I'm going to have to return an either monad, right? But so for example, it would look something like so. Hmm. So here's a match URL. It takes the HTTP request, which is the unwrapped value of the monad, and then it returns a monad, which is the either monad, which is on success, it's an HTTP request. On failure, it's a error message. And as you can see, HTTP request is the right, error message is the left in the either. So I hope the previous slide, when I was saying right and left, that connect happened here, right? Let you stare at it for a moment and moving forward. How does this even, why am I taking all this trouble? Like a lot of headache, right? Why? The reason being, I want to be able to do this. You remember the then operator? Likewise, I want to do flat map, which is like native to functional programming within the either monad. And the ability to compose functions is simply too good to resist, right? And how does this even work? I already told you that the either monad has two values, right? And if I have to keep doing flat map, flat map, flat map, which value will get passed? How can I even assume the request is being passed? And that's where this part comes in, which is the either monad is a right biased monad, right? So if it's right biased, what I mean by that is the flat map operator will only apply the function to the right, which is HTTP request. If it's a success, it will apply the next function. If it's a failure, we'll come to it. So that's why we have this ability. Now, if you're looking at this, all this should sound a little familiar to all the more seasoned functional programmers than I am. And maybe you all recognize this gentleman. His name is Henry Claesley, and you might remember this particular operator. It's called the fish operator, or the notation is called the notation for Claesley composition. Now, railway-oriented programming itself is not, directly the same as Claesley composition, but seasoned Haskellers would know that this is very similar, and that's why I just calling it out that a Claesley composition allows chaining functions that return a monad, effectively composing functions, right? You are able to do this chaining where you can take the unwrapped value, operate on top of it, return the next monad. So the next monad will get unwrapped, used by the next function, next method, and then so on and so forth, and you can keep chaining functions. So that's the fundamental there. Again, uh, if you're itching to read some very hardcore theory, you can get into this details, and probably that'll be a good discussion to have later on. But just wanted to call out because there's a lot of similarity and you might be wondering why. So just wanted to highlight that Claesley is very closely related. Coming back to our fellow, I told you that the flat map already is right biased for either monad. So thereby it's only operating on the HTTP request. Now what happens to the errors? And that's when the fold comes in. The fold takes two functions, if left, if right. So thereby, you remember what I did, right? I had earlier chained the functions using then, and then at the end of the then I had an error, and I would shunt out of it. Like if there are any errors, I have to get out of it, right? So exactly like that. So I would keep doing flat maps, match URL, flat map, match body, and then I'd fold. At the end of it, if it's a failure, I'd return a failure. If it's a success, I'd return a success, right? I cannot, like one of the things with monads is once you get into this kind of composition, getting a value out of it is very difficult for me at least, right? At that point, I was wondering, how do I get a value out of the monad? I need to exit this monad chain. And that's when the flat map gives you the fold, that is the exit. It's the end of the line, and then you either get a success or a failure, and then you get out of it. So this is an important aspect. So flat map and fold. Now, all of this put together looks something like this. So a match URL, another request, flat map, match method, flat map, match body. And as you can see, I'm passing it, right, which is nothing but this another request, because flat map is taking the right, passing it here, taking the right, passing it here. And that's why you see it. And finally, you will fold and say whether it's a success or a failure. I'm sure some of you are asking, after all this trouble, this code doesn't look that great. And I agree with you. It does not look that great. What do I mean by that? I have reformatted the code, which you saw in the earlier screen, in the screen. I'll again let you stare at it. It's a match URL flat map, match body flat map, then fold. It's exactly the same match URL, match method, match body. There's still the flat map going on. What's the difference then? I've just formatted the code to keep the business end on the left and have the machinery on the right. Right? So what's happened here is, again, the machinery is a little bit of code that I don't need to have in the way which affects my readability. I again want to have that kind of beautiful chaining without having to deal with, the flat map getting in the way of my readability. So which is exactly why, let me quickly jump back into IntelliJ. And let's look at the code which I have written here with Arrow. This is the Arrow code. As you can see, I don't have any custom code at all. I don't have any then or anything like that. It's just purely flat map and I can keep moving forward. And this is where I found it difficult because it's not readable anymore, because match URL is here, match method is here, match body is here. It doesn't look that nice, right? So I'm gonna split this right. In fact, let me open the other guy. Sorry about that. With the infix function. So let me extract this. So I'll split this right, and I'll open on the left the only arrow. I'll close this. So as you can see here, the flat map is getting in the way of my readability. So what I then did is, instead of having to deal with that machinery sitting in the path of what I had to do, I have still come back to this beautiful setup, which is I can keep the business end visible to people who want to read. And I brought back my then and handle error with my beloved functions here. And those functions, I have now rewritten them. Instead of the result type, I've started using flat map and the fold. And that's pretty much all. So practically all the code that you saw earlier, which I had written with the result type, have come to this point also, and I've closed it out. So now quickly to recap, once I have the business end and the machinery separated, I can go extract the error handling and bringing back the then and the error handling code. And finally, this is the setup. So putting it all together, this was about like a week's worth of work, which I polished again and again over the past several years. And every time I go, I think this has been like reusable code, which I have been able to uh, use to avoid if-else condition checks when I'm trying to go through an error, a lot of error checks. And that's how I have this railway-oriented programming setup right here. So with that, uh, I'll stop. I'll again have some links and stuff shared later on for the blogs that I've referred to. But this is my learning and experience in terms of using railway-oriented programming in the context of the project that I've been working on. So thank you again for being a great audience. I'll stop now, and any questions I'm happy to take. By the way, all the code that I showed is available on GitHub. This is the link. You can pick it up from there, and would love to hear feedback.
We do have one question. Hari, what do you think of the disadvantages of this programming model?
Right. So it's not like this is a very, I can't use this too widely, right? I think that's the mistake I made. Sometimes what happened is, for a smaller use case, when I tried to use the railway-oriented analogy, it just felt like the the machinery itself was more than what was the necessary code that needed to get done. So the question I had to ask repeatedly for myself is it worth all the trouble? So if you have like a chain of functions you have to compose, and the composition is really critical to the business readability of your code, then it's worth it. If you had only like 2 or 3 functions, I think even getting away with that little bit of guard clauses would be sufficient. So for me, the return on investment is the primary thing. In order to achieve a certain return on investment, you should have the complexity that justifies like this, right? If you have like 10 functions which I have to compose, then this is certainly justified. But if you had just 2 or maybe less than 3, then obviously it doesn't make sense to take all this trouble.
Thank you, Hari.
Thank you
Thanks
for
for
the
taking out
advice.
time for us. Thank
Thanks,
you.
Anupa, for hosting me. Thank you. Bye-bye.